you. In this lecture, we will discuss about the recurrent neural networks, which is most important in sequence generations. Okay, here what is mean by recurrent neural network is here what is the difference between the recurrent neural networks and earlier we know that artificial neural network ANN and in ANN we are using some neurons. Okay, then we are also using some hidden neurons, that is a hidden layer and one output layer. If it is for the binary classification, if it is a multi-class, then we are using two more or three more according to the how many classes are required at the output side. And here, whatever the input I am giving, some x1, some x2, it is connected to the all the layers. Okay, and it will process the data and gives the output. Depending on if it is a multi-class, that means we are using softmax activation function. So it will give the some resultant answers. Here, whatever the input, they are directly processed by this all the neurons using some mathematics, then giving the output. But here we can find that there is no storage element or nothing is stored in this network. So that is the drawback in ANN. But when we are coming to the recurrent neural networks, it had some storage element. That means it receives the data from the previous output while performing the current input. So that is the major advantage of the recurrent neural network. That's why they are using this one in the next sequence, that is a sequence generation. Okay. So here the architecture of the RNN is like this. Here HT is a current state, HT minus 1 is the previous state, and XT whatever we are going to the give the input, and YT is the current output. Whatever the HT we are next forwarded to the future HT plus 1 also. So here there are two the applications if I am coming for the RNN is one is a natural language processing used in natural language processing, and another one is a time series predictions. Okay, it can predict the future values. So here xt is the input and ht1 is the previous hidden state, ht is the new hidden state, and the activation function which we are using, it is a tan h, and that is it's a combination of previous state as well as current input and bias also here. Okay, and yt, it is obviously ht multiplied with wy plus b naught if I am taking another bias term. Okay, this is the architecture of the RNN, recurrent neural network. Okay, then if I'm let us go to the some applications. Here I have taken to predict the what, that is if I'm typing a, then a has to come, then if I'm giving a, then t has to come. This is the simple three letter what I have taken and which is implemented by the RNN network. Here wx, according to this one, see here weight of the input, weight of the hidden layer, weight of the states and weight of the outputs already given. So here then next one is we have to, because this is letters system cannot understand, so we have to convert it into the binary terms. That is called as a low level language, and it consisting only zeros and ones. So therefore we need to we need some mechanism to convert this data. So that is called as a simple one hot encoding. Okay, the concept name is called as a one hot encoding. So what is meant by one hot encoding means whatever the letter we are taking, that will be converted into the some binary zeros and ones. And here if I am taking some 8, KT8, it is only two letters. Therefore, the matrix is only 1, 0, and that is A equal to 1, 0 I am representing, and T equal to 0, 1. So A and T are purely independent. Okay. And if you are taking three letter CA, T, then C equal to, I am representing 1, 0, 0, and A equal to 0, 1, 0, and T equal to 0, 0, 1. This is called as a one hot encoding. So accordingly, if you see, I need to represent from A to Z, then the matrix size is simply 26 rows by one column. So there A is the starting place and Z is the last one. It is not mandatory that one is has A has to become like this only. So that is a representation depending on the applications. Okay, they can change anything, but all must be independent. Okay, so this is the one hot encoding. So here I have used in this one hot encoding, that is C equal to 100, A equal to 010, T equal to 001. Okay, so this is one hot encoding, and now I have applied this input to the HT. The HT formula already we know, that is tan H, that is multiplied with the hot, that is weights of the states and previous state. Here previous state we are considering 0 because initialization we have to give the 0, and current input Wx we know, X is the C I am giving. C if I am giving, then A has to come. After if I am giving A, then T has to come. This is our target by using RNN. So then X I have taken as a C. So after multiplication of substituting this all the weights and inputs in the HT, then performing the tan H operation, finally we got minus 0.626, 0.756. Okay, before doing this operation, we have to careful about the matrix dimensions. Okay, next one, the HT means here we got it. This is HT, current state outputs we have obtained. Now, with the help of this current states and WY weights, we can get the current YT. So, WY already we have taken, and HT we have obtained. Then B naught, right now I am taking, there is no bias. Okay, 000. Then after multiplying, finally we got. Then after this one, we have to apply the softmax, or the softmax by using their dimensions, or this one also can be applicable. So the softmax formula is e to the power of z1 by e to the power of z1 plus e to the power of z2 plus e to the power of z3. So z1 is the 0.32 first one, z2 is second one, and z3 is third one. So after performing the all the softmax, we got 0.175 for the z1, 0.735 for the second one, 0.088 for the third one. So whichever is the majority one, we have to take it as a 1, and remaining all we have to consider it as a 0. So here we have obtained 0, 1, 0. See, I have given 1, 0, 0. I have obtained 0, 1, 0. That means if I am giving A, then A is obtained. So that is the answer. It means given C and obtained A. In the stage number 2, there itself, now I am giving. HT states are like this. These are the HT current state outputs that is given, and A already we have output. So that A we are feeding to the XT plus 1 as a input to the next state. Okay, WX and WH, WA are common in these cases. And now we need to find the HT plus 1. So the formula is again common for same HT plus 1. Here, sorry, it's HT plus 1. So tan H, WH into HT plus WX into XT plus 1 plus D. Bias still I am taking the zeros. Then after WH and WY, WX are common. So after substituting this one, now the previous state we have taken 0. Previous state this HT minus 1 we have taken 0, but right now we have the values of minus 626 and minus 0.626 and 0.756. So after substituting these things, then finally I got 0.077 and minus 0.999. So again, HT plus 1 we got it. We know YT plus 1 formula. HT plus 1 multiplied with WL plus B naught. So B naught is again 0 I have taken. So this matrix actually interchange because this is a 2 by 3 by 2 and this one is a 2 by 1. So after multiply this one, we finally got YTS like this. If you apply the softmax, then finally we got this answer after applying the softmax on this one. So then this become whichever is higher value I said already. So Z1, Z2, Z3, then we have taken YT plus 2 these things. Okay, YT plus 1, second one is third one. Then finally we got the higher value file last one. So therefore that is this is 0 and 0 and 1. So 0, 0, 1 means we got, see, come to here, 0, 0, 1 means what we have taken T. So that has obtained by our mathematical calculations. And the resultant diagram, if you check here, HT minus 1, I have given C, we got A in the first case stage, and the same A I have given over here, then we got T. That likewise, whatever the sequence generation can be obtained by using this RNN. And here the weights I have properly taken, that's why there is no loss. But sometimes what will happen, instead of 001, if it is 010 is obtained, then we have to find the loss, then go for the back propagation. So back propagation mechanism I will explain in the next lecture. Thank you all.